to talk about complex numbers and quadratic equations. So this is section 1.4 and 1.5 in your text. So the definition of a complex number. Okay, so the square root of a negative number. Up until today, every class you've had and every teacher you've had has most likely told you that there is no such thing, right? You can't take the square root of a negative number. But what if there were such a thing, right? It seems crazy, but we're just going to invent it. We're going to say, yeah, let's pretend it exists, and we're going to call the square root of -1 the letter I. And I stands for imaginary. So it's not real. The real number system is what we've been studying up until today. And now we're going to have this other kind of number called an imaginary number. And it might sound crazy to just invent a new kind of number, but all the different kinds of numbers you know about at one point didn't exist, and then somebody said, let's invent a kind of number that describes a certain phenomenon that we need to describe, like negative numbers, right? When humans first started using numbers, we used them to count. And the number -2 just was like, that doesn't make any sense, right? But we invented them to describe certain phenomenon, like going underground or below freezing or owing money to somebody, right? So we invented negative numbers to describe a certain thing that we wanted to describe when they didn't exist before. Same thing happened with rational numbers and irrational numbers. So it's not quite that crazy that we're just inventing this new thing out of nowhere. We would like to have some way to describe the square root of a negative. So we'll say, okay, let's say it exists. The square root of -1 and is going to be I. We're just going to give it a name. So that means that if k is a positive real number, if you want to take the square root of -k, that breaks down to the square root of -1 times the square root of k. And square root of -1 is I. So we get I square roots of k. So let's do a couple of examples. If I want to do the square root of -49, I could break that down to the square root of 49 times the square root of -1 using the rules of radicals. And then what's the square root of 49? 7. And what's the square root of -1? I. So this is 7I. Yes. Yes, I just rewrote -49 as +49 times -1. Yeah. So if I want to do the square root of -8, I would write that as the square root of +8 times the square root of -1. And how does the square root of 8 simplify? 2√2, yeah, it's not a perfect square, but I could break it down to 4 times 2 and take the square root of the 4. So this ends up being 2 square root 2, and the square root of -1 is I. And you can leave it like that, but very often we might write 2I square root 2, because I just like to put the radical last, but that's a personal preference, because you can do multiplication in any order. Yeah.
Going forward, it's just
Yeah, you can treat I just like the way you treat a variable. Yeah, but just keep in the back of your head that it's representing the square root of -1. Yeah. All right, how about I squared? I squared, so that would be the square root of -1, because that's what I is, squared. What do you get? -1. I squared is -1. All right, so let's look at some complex numbers. A complex number is a number that looks like a plus bi. So you've got a real part, like in 2 plus 5i, the real part is 2, and then an imaginary part, 5i. 3 minus 4i, that's a complex number. 5 plus 0i, which is just plain old 5, is a complex number. And 0 minus 7i, which is negative 7i, is also a complex number. So complex numbers look like a plus bi, and that is within the complex numbers are a couple of subsets. We have real numbers that are just like the regular old numbers, and imaginary numbers, which are numbers that have just an I, like 2i or 5i. All right, so we can do complex arithmetic, do arithmetic with complex numbers now. You can add, subtract, multiply, and divide them, much the same way you do algebraic expressions, just like you said. You can just treat that I like you would treat an x or a variable. So if I want to add two complex expressions, I just combine like terms, combine the real parts, 2 plus 1 makes 3, combine the imaginary parts, 3i and 5i make 8i. Subtract complex numbers. Again, you just have to remember to distribute this negative sign just like you would if those i's were variables. 2 minus 1 is 1, 3i minus 5i is negative 2i.
Just like
Correct. Right. Yeah, you can't, these would be not like terms. Yeah. Okay, 2 plus 3i times 1 plus 5i. So when you're multiplying, again, you're going to treat that I just like it's a variable. And so I'm going to FOIL these. I'm going to distribute, and I get 2. And that's my first. And my outer is 10i. And my inner is 3i. And my last is 15i squared. But what was I squared again? Negative 1. Yeah, back here, 2c, we decided that I squared was negative 1. So I'm going to replace that I squared with a negative 1. And I'm going to combine those like terms. So I have 2 plus 13i plus 15 times negative 1. But what's 15 times negative 1? Negative 15. So this is 2 plus negative 15 is negative 13. So this is negative 13 plus 13i. All right, you guys multiply part E. FOIL out 2 plus 3i times 2 minus 3i. 2 plus 3i times 2 minus 3i, we're just going to FOIL them. So first, 2 times 2 is 4. My outer and my inner are the same, but one's positive and one's negative, right? I get negative 6i and positive 6i, so those cancel. And then my last is going to be negative because it's a positive times a negative. And 3i times 3i is 9i squared. But I squared is negative 1, so this really says 4 plus 9, right? Because 9 times negative 1 is negative 9, so this is 4 minus negative 9. 4 plus 9 is 13. So something special happened in that last example. I multiplied two complex numbers that had imaginary parts, and I got a real number, right? A plain old 13. Thanks. So that's a special thing, and that can come in really handy, but to multiply two complex numbers and get a real number. So those two complex numbers are called conjugates, 2 plus 3i and 2 minus 3i. And the conjugate of any complex number, a plus bi is a minus bi. And the conjugate of a minus bi is a plus bi. So the conjugate of 2 plus 3i is 2 minus 3i, right? So it can be helpful to have a shortcut for multiplying two conjugates together. And it ends up that when I FOIL these, I always get a squared plus b squared. The i's end up going away. So the last thing about complex numbers and how to do arithmetic with them is that you always want to write a radical in terms of I before you do any operations. So the reason, I'll show you the reason after. So if I want to do radical negative 20 times radical negative 5, I want to take the negatives out and make them i's. before I do any operations. So I would do radical 20 times radical -1. That's my radical -20 times radical 5 times radical -1. So this is radical 20i times radical 5i. So we want to change them to be written in terms of i's before we do any multiplying. Now I can multiply stuff. Radical 20 times radical 5 is radical 100, and I times I is I squared. And then what's radical 100? 10, and what's I squared? -1. So this is 10 times -1, which is -10. Now, if I had not taken the negatives out first, you might think that you could do this. Radical 20, -20 times -5. The rules of radicals say that you can multiply what's under the radical, right? So I would do -20 times -5, which is 100, and radical 100 is +10. Right? But it seems like the essence of this problem is different than radical 20 times radical 5. And when you're dealing with i's, you want to pull them out before you do any arithmetic. So this is not how you do it. Pull out the i's first. So you may be asking yourself, why are we inventing complex numbers right now? And the answer is because sometimes they're the answer to a quadratic equation, as we'll see. Sometimes you get complex numbers as the answer to a quadratic equation. So a quadratic equation is an equation that has a x to the second power in it. So a linear equation is an equation that has just a plain old x. A quadratic has to have an x to the second power. And the general form of a quadratic is ax squared plus bx plus c equals 0. And a, b, and c are just numbers. So we're familiar with techniques used to solve linear equations. We reviewed that earlier in the course. Now we're going to learn some techniques for solving quadratics. So the first technique is used when you can make the equation look like ax squared equals c, or some stuff squared equals c. If you can have some stuff squared equals a number, that can be solved by taking square roots, using the square root property. So if z squared equals 9 and I want to get z by itself, how can I undo squaring? Square root. Okay, so to undo squaring z, I would square root. And what is the square root of z squared? Be careful. Yes, and you could say that absolute value. The square root of z squared is the absolute value of z. Yep. And the square root of 9 is 3. So if the absolute value of z is 3, what could z be? 3 or -3. Because the absolute value of 3 is 3, and the absolute value of -3 is also 3. So if you have some stuff squared equals a number, you can just square root both sides. So here's another example. I've got x squared equals -25. To make that x squared, I just want a plain old x. So to undo squaring, I square root, square root, square root. The square root of x squared is the absolute value of x. What's the square root of -25? 5i, yeah. Because the negative under the square root becomes the square root of -1, which is an I. And the square root of 25 is 5. So this is 5i. Now, if the absolute value of x is 5i, what could x be? Plus or positive or negative 5i. Because the absolute value of 5i is 5i, and the absolute value of -5i is 5i. Yeah, so I looked at the square root of negative 25, and I wrote this as the square root of 25 times the square root of negative 1. And the square root of negative 1 is I. I want the final solution, the plus or minus. Yeah. So many people, once you have solved a lot of these equations, might skip writing down the absolute value step and just go right to the plus or minus. That's fine, but I'm always going to do it because I want you to remember, because it's so common to say square root both sides, z equals 3, right, and forget the negative one. So I'm just going to keep doing the absolute value until everybody always remembers. Okay, so for C, I need to make this look like some stuff squared equals a number. So the first thing I'm going to do is I want to isolate the stuff squared. So my stuff here is the x minus 7. I have an x minus 7 squared, but I want that by itself before I square root. So I'm going to divide by the negative 2 first. So those cancel, and I get x minus 7 squared equals 10. Now I can use my square root property and I can square root both sides. Square root, square root. What is the square root of x minus 7? The absolute value of x minus 7. And if the absolute value of something is radical 10, then that means that whatever that something was, it could either be radical 10 or negative radical 10. So I have two equations that I can write from here. Either x minus 7 is radical 10, or x minus 7 could be negative radical 10. Whatever I'm taking the absolute value of could be positive or it could be negative. And then solve both of these equations by adding 7 to both sides. So we get x equals 7 plus radical 10, and x equals 7 minus radical 10. Or you could write it as one statement, 7 plus or minus radical 10. There's several other approaches you could have taken for that particular problem. We could have squared out the x minus 7, distributed the negative 2, and solved it another way. But I just wanted to show you the square root property. So my next technique, before I move on, any questions before I move on? Yeah. Yes, they're both solutions. Yeah, both of those are answers. And the other problems, A and B, both of those had two answers too, right? I just wrote them as a single statement, but this is positive 3 and negative 3, both solutions. Okay, so I'm going to show you a total of 3 techniques for how to solve quadratics today. So that's one of them. Try to make it so that you can take the square root of both sides. All right, the next one is called the zero product property, and it's this really special property about the number 0. And it says that if you multiply two things together and the answer is 0, the only way to make a product, to make the answer to a multiplication problem be 0, is if one or both of those factors are 0 themselves. So like I try to think of a multiplication problem whose answer is 0. 0 times 5. 8 times 0, right? The only way I can get an answer of 0 is if one of the factors is 0. So I'm going to use this special property of 0 to help me solve quadratics. So The goal is to factor one side of the equation has to be 0, right? Because that's the only way the zero product property applies, is if you're multiplying two things and the answer is 0. So I want to rewrite x squared plus x as a product, as a multiplication problem. So that means I have to factor it. So how do you factor x squared plus x? I can take out an x. There's an x in both terms there. I'm going to factor it out. So what do I multiply x by to make x squared plus x? X plus 1. So now I have a product. I'm multiplying two things together, x and x plus 1. The answer is 0. So one of these two things has to be 0. Either x is 0 or x plus 1 is 0. And then you solve the two equations. So we get x equals 0 or x equals -1. Those are both solutions to the equation. So for part B, I have a quadratic, and it's equal to 0. If I could rewrite the left side of the equation as a multiplication problem, I could use the zero product property. So can I rewrite that as a product of two factors? What are my factors? 8 and 3. X plus 8, x plus 3. And so now I've rewritten this as a multiplication problem, which means I can take each factor and set them equal to 0, right? Either x plus 8 is 0 or x plus 3 is 0. That's the only way I could get an answer of 0 when I multiply them together. So that means that x equals -8 and x equals -3 are my two solutions. How about x squared minus 49 equals 0? It factors to x plus 7x minus 7. And then I set each factor equal to 0 and solve it. X plus 7 is 0, x minus 7 is 0. So I get x equals -7 and x equals +7 as the two solutions. Yep, we could write that as one single statement, x equals plus or minus 7. Good. What's another approach I could have used on this particular problem? The square root property that we learned earlier. I could have moved the 49 over to the other side and then taken the square root of both sides. And I would get the absolute value of x is 7, which means that x is either positive or -7. So you get the same answer, different approach. So just keep in mind here, we solved all of these problems by factoring, but factoring is only useful if the other side of the equation is 0, right? So if you have two things multiplied together and you get 8, there's nothing you can say. It doesn't mean that one of those two factors has to be 8, right? Because you could have 4 and 2 or 8 and 1, right? There could be a lot of different factors. So it has to be that the one side of the equation is 0 to use this special property. All right, the third method for solving a quadratic is the quadratic formula, probably something you saw in a previous math class. If your equation is ax squared plus bx plus c equals 0, then you can plug a, b, and c into this formula and figure out what the solution x is. So we have a little math version of Pop Goes the Weasel. I am, but I'm going to stop the recording. Formula. All right, so I'm just going to do a couple of these because we're running out of time, and I want you to have time for the quiz. To solve with the quadratic formula, the first thing you have to do is have one side be 0. Right? And then after that, you have to identify A, B, and C and plug them into the formula. So let's do B together. We'll do part B. So the first thing I have to do is have one side of this equation be 0. So I have to move everything to one side. So this is going to be 5x squared minus 20x plus 6 equals 0. I just subtracted 20x from both sides and added 6 to both sides. And then I'm going to plug into the quadratic formula. So in this case, what is A? 5. The coefficient on the x squared is your A. What is your B? Negative 20. The coefficient on x is a negative 20. And what is your C? 6. So A, B, and C are your coefficients of the x squared, the x, and the constant term. So we've got 5, negative 20, and 6. And then we plug those values of A, B, and C into the quadratic formula. I'm going to write it over here. So plug in, and I'm going to put negative b, but b is negative 20, so what is negative b? 20, yeah. Negative 20 is 20, or think of it as the opposite of negative 20. So negative b, that's 20, plus or minus the square root of b squared. What is negative 20 squared? 400. Is it positive or negative 400? It's positive, because anytime you square anything, it comes out positive. Because negative 20 squared means negative 20 times negative 20, which is positive 400. Okay, 4 times A, which is 5, times C, which is 6. All over 2 times 5. So I'm just going to simplify a little bit at a time here. 4 times 5 is 20, times 6 is 120. So I have 20 plus or minus radical 400 minus 120 is 380. Yep, thank you. $280 all over 10. And can we simplify radical 280? 2 radical 70? That's the best we can do? Okay. So this is going to be 20 plus or minus 2 radical 70 all over 10. And then you can factor a 2 from both of the terms in the numerator. So this would be fine. So first of all, let me just say, if you circle that or you circle that on a quiz or a test, I'm cool with that. I just want to show you how to reduce it. So if you're like comparing your answer with a friend or something, and you get two different things, you'll see that they're really the same thing. So from this numerator, I can factor out a 2. So that's going to be 2 times. So 2 times what gives you 20? 10. And then 2 times what will give you 2 radical 70? Radical 70 over 10. And then I can reduce the fraction 2 over 10 to 1 over 5. So this final answer is 1, 5, 10 plus or minus radical 70 over 5. Yes, you can do that also. Yes, that's another way to think about it. Yep, that's fine. Yeah, and that's a good thing to show. Let's see. So I have 20 plus or minus 2 radical 70 over 10. So what that back table back there was just asking me is that can't you do this? 20 over 10 plus or minus 2 radical 70 over 10. And then reduce each fraction separately. Yes. Yeah, because this is like sort of doing adding fractions in reverse, right? When you add fractions, you need a common denominator. So if I was going to add these, I would get this. So I can break it back down into 2 fractions. And then I can reduce them separately, and I get 20 over 10 is 2 plus or minus radical 70 over 5. So you could also write it like that. Good. All right, so we'll just do one example with the quadratic formula because I got to get the quiz started. And I'm going to have you read that part of the notes on your own for homework.